Okay, so let us continue our discussion, guys, ng double integration method. So let's now solve the example problem number 2. Okay, so I will read first the problem. A beam 15 meters long is simply supported at its ends. The beam is loaded with a downward vertical load of 120 kilonewtons at a point 10 meters from the left support. Okay, so the questions are: determine the maximum deflection. The maximum deflection is located at what distance in meters from the left support? Letter B, calculate the maximum deflection in millimeters. And letter C, calculate the rotation of the beam at the right support. That is in radians. Okay, so kulang lang yung problem, guys, no? That should be in radians. Okay, so so this time, guys, yung ating problem is multiple segments, no? Kasi nga yung segment from A to B is continuous, tapos nag-discontinue sa may point B, and then continuous na naman sa point B to point C. Okay. So ayun, so this is multiple segments. So katulad yung diniscuss natin nung nakaraang video, ayun. So ang gagawin muna natin, guys, no, to start the solution is i-drawing muna natin siguro yung elastic curve nitong ating beam, para magkaroon tayo ng idea as to ano yung maaaring maging values, kung positive ba or negative yung ating mga lalabas na sagot sa mga tinatanong dito sa problem na ito. Okay, so ayun, so so dito, i-drawing ko na nga yung ating elastic curve. So this is just an approximate na elastic curve. Hindi natin alam kung tama ba to, no? I mean, hindi ito exactly na ito talaga yung itsura, no? Depende yun sa result, no? Pero ito yung magiging almost na mukha ng ating elastic curve. Okay. So, isa-isayin muna natin, guys. So, letter A, kailangan natin yung distance ng maximum deflection. So, ayun, so dalawa lang yung guess natin dito. It's either yung maximum deflection is nasa first segment o di kaya nasa second segment. So ako, wala tayong proof dito kung saan talaga yung ating maximum deflection, pero if I were to judge, I think nasa first segment siya, no? Kasi ano lang, based on my tawag dito, intuition or whatever, kung anong tawag doon. Okay? So ayun, so hindi ko alam, so wala akong masyadong sagot sa letter A, no? Okay? So letter B na lang tayo, guys. Calculate the maximum deflection of obviously yung ating maximum deflection will be negative kasi lahat naman dito ng ating deflection ay negative. So ang ina-expect natin dito na sign ay negative. Okay? So anuhin lang natin. Tapos, para naman sa letter C, calculate the rotation of the beam at the right support. So, yung right support natin, guys, nandito, that is support C. So, kung magdodrawing tayo dito ng tangent line, ito yung tangent line na magdodrawing natin. Okay? So, obviously, this is a positive na tangent, na slope ng tangent. So, positive yung ina-expect natin na sign dito sa letter C. Okay? So, that's it, guys. So, yun yung ating mga assumptions, mga hula na maaaring maging results. Okay? So, mamaya, no, sure na tayo na negative sa letter B at saka positive sa letter C, no? So, ayun. So, anyway, no, mamaya ay find out natin kung ano yung mga exact na mga values nitong mga nandito na sagot, mga dapat na sagot nito. Okay? So, ayun. So, una natin gawin, so una natin gawin, guys, no, ay i-solve muna natin yung ating mga reaction sa ating support. So take note na simply supported yung ating beam. So ibig sabihin, no, we can just compute for the vertical reactions, no. So madali lang naman to, hindi ko na ipapakita, guys, yung ating solution dito, no, kasi nga madali lang naman to. So ang ating reaction dito sa A is 120 times 5 divided by 15. This is 40. No? This is 40 kilonewtons. And then dito sa C, this will be 150 times 10 divided by 15. This will be 80 kilonewtons. Okay? So, yun yung ating mga reactions, guys. Ito yung ating reaction sa A at ito yung ating reaction sa C. No? So, ayun. Okay, so ngayon naman, guys, ay i-cut natin siya sa last segment. Diba nga, sabi nga natin sa ating sa ating tip is kapag multiple segments, doon tayo magka-cut sa may last segment. Okay? Okay, so dito tayo sa last segment mag-cut and then i-isolate natin yung left side. Okay, so ayun. So cut natin dito, guys. Okay? Then i-isolate natin yung ating left side. Okay, so left side tayo. Okay, i-isolate ko muna, guys, no? Ayun na nga, guys, no? So in-isolate ko na yung left side. So dito tayo. So bali ayun, so um yung ating kinata section ay dito. So bale itong distance na to is tatawagin natin x, okay? Tapos of course, ang hinahanap natin dito is kailangan nating makagawa ng moment equation. So that is the general moment equation. Ayun, so m yung hinahanap natin. So ayun, so bale no, ang gawin natin, guys, ay mag-summation of moment tayo uh, about this point sa may kinat natin na point, okay, equals to 0. Ayun, wait lang. Okay, so summation of moment about this point nga is equals to 0. Ayun, so let's assume a counterclockwise rotation to be positive. Okay, so of course kasama dito si M. Nakikita mo pa ba? Okay. So of course kasama dito si M, guys. So M is positive. Ayun. Then minus 40 times X. Okay. Then minus 1 plus, okay, wait lang. This is plus 120 times X minus 10. Then equal to 0. So ayun. So tama ba, guys, no? So ayun. So kailangan natin ng equation dito ng moment. So ang gagawin natin is ita-transpose natin lahat ng terms na to other than M sa kabilang side ng equation. So ang mangyayari is, of course, M is equals to, this is 40 and then X, okay, and then minus 120 and then X minus 10. Okay, so i-close lang natin, guys, sa pointed bracket yung ating mga variables. So enclose natin to sa pointed bracket, enclose natin to sa pointed bracket. Okay? So ayun, so ito na nga yung ating moment equation, guys. So ano yung gagawin natin? So pareho din sa last na example. Ayun, so ilalagay natin ito mamaya sa ating mga equations. Okay? Ayun, so unahin muna natin, guys, yung ating moment equation. So ayun, so ito yung ating guys, no, ating maging moment equation. So ayun, so bali EI d squared y over dx squared is equals to m. Okay? At yung m nga natin ay nandito sa taas. Ayun. So bali no, ilalagay lang natin. Okay? So this will be 40. Wait lang. Okay, this will be 40, then x minus 120, then x minus 10. Okay, so this is our moment equation. Ayun, so ilagay lamang natin, guys, dito yung ating unit ng ating moment equation. So since moment nga ito, guys, then ang ating unit dito is, ayun, so this is nga in kilonewton. Yung ating unit ay kilonewton meter, no? Kasi nga naka kilonewton yung ating force and yung ating distance is in meter. Okay? So kilonewton meter nga yung ating unit para sa bawat terms nga ng ating moment equation. So ito na nga, guys, yung ating moment equation. So yan na yung final natin na moment equation. So now, no, i-integrate natin ito para naman makuha natin nga yung slope equation. So again, so kailangan lamang natin i-integrate and then integrate sa magkabilang side ng equation para makuha nga natin yung slope equation. Okay. Okay, so para sa slope equation, so again, integrate natin, no? So EI, wait. Okay, EI, dy over dx. So again, integral natin ng d squared y over dx squared is dy over dx is equals to, integral natin ng 40x is 40, then x, ayun, then square divided by 2, then minus, okay, then 120. Okay, so take note, guys, no, para hindi tayo guys, take note, no, na itong nasa loob ng pointed bracket is considered as a whole na variable, no? Hindi nyo pwedeng paghiwalayin yung x minus 10. So pag integrate natin siya, guys, no, isang whole variable na lang yung x minus 10. So pag integrate natin siya is magiging x minus 10 then square divided by 2, no? Kasi nga isang buong variable yung nasa loob ng pointed bracket. So ayun, so kailangan yung tandaan, guys, niyan, no? Kasi pag pinaghiwalayin mo siya, and then saka mo in-integrate, no, mamamali ka for sure. So ayun, so mayroon pa tayo ditong plus C1, ayun. So ito na nga yung ating magiging slope equation. Okay, so yung unit natin, guys, na ating slope equation is, of course, this is in kilonewton square meter. Okay? So hindi pa to final, guys, no, kasi kailangan pa natin makuha mamaya si C1. Okay? So ayun, so para naman sa ating deflection equation, all we need to do is integrate ng isa pa, ayun, para makuha nga si deflection equation. Ayun, kasi nga double integration method nga ito. Okay? So integrate natin, so magiging so EI, then Y is equals to integral nga, okay, integral tayo ha. So EI, integral of dy over dx is Y. And then, okay, wait lang, guys, no, i-simplify muna natin dito sa taas para hindi tayo nahirapan. So dy over dx is equals to 20x, ayun, squared minus 60, then x minus 10, ayun, then squared, then plus C1. Okay. So dito tayo sa baba, so magiging 20x, ayun, then cube divided by 3, then minus 60, then x minus 10, ayun, this is cube divided by 3 na naman, then plus C1, then x, okay, then plus C2. Okay, so ito yung ating deflection equation, guys, no? I-simplify muna natin para mas madali yung ating pag-solve later on. Okay? So this will be EIY is equals to 20x, ayun, this is cube divided by 3. Huwag nyo natin i-ano nito ha, kasi hindi naman to rational. So ayun, so okay, so minus, this is 20x minus 10. This is cube, and then plus C1 x, okay, and then plus C2. Okay? So ayun, guys, no. So ito na nga yung ating deflection equation na hindi pa final kasi wala pa tayong C1 tsaka C2. Ayun, so ilagay lang natin yung ating unit dito. So this will be, so kung yung ating slope equation is kilonewton square meter, then dito is magiging kilonewton cubic meter. Okay? So wait lang. This will be kilonewton cubic meter. Okay? So, ayun, guys, no? So, ang gawin natin ngayon is mag-boundary conditions na tayo. Okay, so, ano yung mga gagamitin natin for boundary conditions? So, again, no, guys, no, ay titingnan natin yung behavior ng ating mga supports tapos doon tayo kukuha ng para sa boundary conditions. Okay? So, tingnan muna natin, guys, yung ating original na beam. Ayun, so ito yung ating beam, guys. So dito tayo kukuha ng ating boundary condition. So una is yung ating support sa A. So dito sa hinge, so we know na kapag ka-hinge, bawal yung kanyang vertical displacement. So of course, no, at x equals to 0, that is at the hinge, yung ating y is equals to 0. So yun yung ating first na boundary condition. Okay? So ayun nga, guys, no? So ito yung ating boundary condition, first na boundary condition. At point A, wherein nandun yung ating hinge support, which is x nga is equals to 0, yung ating deflection doon, y is equals to 0. So ayun. So gamitin natin ito, guys, na condition, na boundary condition, para ma-solve natin yung isa sa mga constants of integration. So kay C1 tsaka kay C2. Okay? So, of course, no, since y yung involved dito, edi gamitin natin si deflection equation. So, ito na nga sa deflection equation, guys. No, kinopya ko na siya. So, EIY is equals to, ito nga yung ating, again, no, hindi ko na siya babasahin. Okay? So, substitute na lang kaagad natin siya, guys. No, of course, yung ating y dito sa kabila ay 0. So this will be equals to 0. And then, okay, x natin ay 0. So obviously, magiging 0 ito. Okay? So kung 0 yung ating x, take note na kung 0 dito guys, no? Kung 0 yung ating x, magiging negative itong nasa loob ng ating pointed bracket. At ang sabi natin guys, no, kapag ka negative yung nasa loob ng pointed bracket, hindi siya isasama sa computation. Okay? So, ayun. So, hindi natin siya isasama sa computation kasi magiging negative 10 man to. Okay? Then plus, okay, dito tayo. So, 0 si x. So, magiging 0 yung buong term na to. Tama ba? And then plus C2. So, obviously, yung ating C2 is equals to 0. Okay? So, yun. So, nakuha na natin guys is C2. Okay, so take note guys, no? Hindi laging 0 si C2. Baka kasi isipin nyo, lagi naman 0 yung lumalabas. So, no, not necessarily guys. No? Not necessarily. Okay? So, yun. So, ngayon naman ay compute natin si C1. So, kailangan pa natin ng isa pang boundary condition. So, balik tayo dun sa beam natin. And then, hanap tayo ng isa pang boundary condition. So, yung isang support, yun yung ating gagamitin. Okay? Okay, so nandito tayo guys sa ating beam ulit, okay? So ayun, so bali yung ating pangalawang boundary condition na gagamitin is itong support na to. So that is at x equals to 15, okay? So at x equals to 15, obviously, so ito ay roller na support. So hindi siya din pwede magkaroon ng deflection dito. So at x equals to 15, yung deflection is also equal to 0. So yun yung gagamitin natin na second na boundary condition. Ayun guys, so ito na nga, no, at x equals to 15, y equals to 0. So again, yung involved natin dito is y at saka x. So yung deflection equation pa din yung ating gagamitin. So ito yung ating deflection equation. So all we have to do is to substitute nga yung ating mga values na y at saka x dito, and then makakuha natin si C1. Si C1 ang ating makakuha dito, ha. Okay, so y natin is 0. So 0 yung buong term sa may kabilang side. 0 ito equals to, okay, so this will be 20 times 15, then cube divided by 3, then minus. Okay, so nag-substitute tayo ng 15 dito, magiging positive yung nasa loob ng pointed bracket. So, kakonsider natin siya. So, minus 20 times 15 minus 10, then cube. Okay. Then, plus C1 times 15. Okay, then plus 0. Okay, so ngayon guys, no, ay makukuha natin dito si C1. So ang lalabas na C1 guys is equals to, okay, sandali. Negative 4,000 over 3. So, ayun. So, ito nga yung lumabas, guys, na value natin C1. So, C1 natin nga, yung ating unit dito is kilonewton square meter. No? Kasi nga, kilonewton cubic meter man to is C1x man to. So, ayun. So, C1 natin nga is negative 4,000 over 3. Okay? So, ang gagawin natin ngayon, guys, ay of course, nababalikan natin yung ating slope equation at saka yung ating deflection equation at i-substitute natin doon yung ating C1 at saka C2. Okay? Okay, so isulat lang natin dito guys yung ating slope equation. So ang ating slope equation na guys nga is EI, then dy over dx is equals to 20, then x, okay, squared minus 60, then x minus 10, ayun, then squared, then plus C1. At ang C1 nga natin kanina, sabi natin is 4,000 over 3, so minus negative 4,000 over 3, so minus 4,000 over 3. Okay, so ito na nga guys yung ating slope equation. Okay, so dito naman tayo guys sa ating deflection equation. I-rewrite lamang natin siya. So ang mangyayari sa ating deflection equation will be EI y is equals to 20, then x, then cube divided by 3, then minus 20, then x minus 10, okay, then cube, then plus C1 natin is 4,000 over 3 negative. So, ayun lang natin guys, no? So, this will be equal to negative minus 4,000 over 3, then x, okay? Then C2 natin is 0, so hindi na natin kailangan ilagay nga si C2 dito, okay? So ito na nga guys yung ating deflection equation. At ang unit nga natin dito is kilonewton cubic meter. So ayun, so nakikita nyo naman siguro, no? So ayun, so ngayon ay pwede natin i-solve nga yung ating mga problems. Okay, so balikan muna natin guys yung ating mga required. So sabi dito sa una, no, ang kailangan nating ma-compute is yung location ng maximum deflection. Okay, so the maximum deflection is located at what distance in meters from the left support. So kung ito yung ating maximum deflection guys, sabihin natin ito yung ating maximum deflection. Okay, so tatawagin natin siyang Ymax. Then, ang kailangan natin makuha dito is yung distance niya from the left support. Ito yung ating kailangan makuha. Okay? Tatawagin natin siyang X max. Okay? So, yun yung ating kailangan makuha dito, guys. So, ayun. So, paano ba natin ito makukuha, guys? No? So, una, no, kailangan natin i-assume saan ba yung ating maximum deflection? Sa first segment ba or sa second segment? Okay? So, punta muna tayo guys dun sa may ating solution. Okay, so para natin siya masasolve guys. So again, no, kailangan muna natin i-assume guys na maaaring nandito yung ating maximum deflection or maaaring nandito sa may kabilang side yung ating maximum deflection. So paano natin malalaman kung nandun nga yung ating maximum deflection sa mga segments na yun na nabanggit, no? Of course, no, yung ating maximum deflection, take note guys, ay meron siyang zero na slope. Diba nga, yung maximum deflection is yung lowest point ng ating elastic curve. So kung ito yung lowest point guys, then kapag nag-drawing tayo ng tangent line sa may lowest point, ito yung lowest point. Pag nag-drawing tayo ng tangent line, lalabas natin ay horizontal, no? Kasi nga lowest point man siya. So yung tangent line niya horizontal, so therefore, yung ating slope niyan is equal to 0. So ayun, so yun yung palatandaan natin ng ating maximum deflection. So I assume muna natin guys na nandito siya sa segment AB, tapos kung hindi siya nandito, edi nandito siya sa segment BC. Okay? So yun. Okay, so yun na nga guys, no? So para sa letter A, that is max, yung kailangan natin makuha dito is yung X max. Okay? So yung location nga ng ating maximum deflection. Okay? So ito yung ating maximum deflection, maximum Y. So of course, we know that maximum Y, yung ating slope dun is equal to 0. So ang kailangan natin dito is yung X max. So ayun, so ano yung gagamitin natin? Slope equation or deflection equation? Of course, ang gagamitin natin guys is slope equation kasi meron tayong given na slope. Okay? So, tingnan natin yung ating slope. Okay. So, una is i-assume muna natin guys. Okay, so ito yung ating slope equation guys, no? So, ayun. So, i-assume muna natin. Okay? Let us first assume na yung ating maximum deflection is located sa segment AB. So that is, i-assume natin na yung ating X max is less than or equal to 10 meters. No? Kasi yung ating segment AB is located at value ng X, no, from 0 to 10. Okay? So, dun muna tayo mag-assume guys. No? Kapag hindi nangyari, kapag hindi natin na-satisfy yung ating X na less than 10 or equal to 10, then ibig sabihin na dito siya sa segment BC. Okay? So, yun. So, balik tayo dito. Ayun. So, okay. So, ang gawin natin guys is, ayun. So, gamitin natin guys itong ating dy over dx na 0 para makuha natin si x. Okay? So, bale no, 0. Kung 0 si dy over dx, that means 0 yung ating nasa kabilang side ng equation is equals to, okay, so again, unknown dito yung x, no? So this is 20x squared. Then, okay, so take note guys, no, kung yung x natin ay less than or equal to 10, Okay, kung less than 10 ito or equal to 10 ito, di ba? Kung equal to 10 ito, di 0 yung nasa loob. Kung less than 10, magiging negative. So, ibig sabihin, hindi natin i-consider itong term na to kasi magiging negative or 0 nga yung nasa loob ng pointed bracket. Tapos, bale, no? Ang isasama na lang natin ay yung ating itong isang constant na minus 4,000 over 3. Okay? So, ayun. So, bale nyo guys, ang lalabas dito na value ng x, ito na yung ating x max, ito na yung location. Ayun. Kung yung lalabas na x natin guys dito, ito yung ating x max, no? Kung yung lalabas guys na ating x is less than 10, then tama yung ating assumption. So, yun na talaga yun. Okay? So, yung ating x max guys is 8.165 meters and it is less than or equal to 10. So, therefore, ito na nga yung ating location of maximum deflection. Okay? Location of maximum deflection. Okay? So, yan na yung sagot guys sa first na tanong. Okay? So, ayun. Okay, so now, balikan natin guys yung ating problem. Okay? So, yung ating problem number 2, calculate the maximum deflection in millimeters. So, madali na lang to, di ba? Kasi nakuha na natin guys yung location, so madali na lang makuha yung maximum deflection. So, ayun guys, no? So, ang ating hinahanap dito is yung maximum deflection. So, nakuha na natin yung location ng ating maximum deflection, that is 8.165 meters. So, madali na lang to, no? So, ayun. So, since deflection yung ating hinahanap, then deflection equation yung ating gagamitin. So, ito na nga guys yung ating deflection equation. Okay, ito yung nagawa natin kanina. So, ayun. So, bale, no? So, y yung hinahanap natin dito. Of course, yung ating x na isa-substitute dito is yung 8.165 kasi nandun nga yung ating maximum deflection. Okay? So substitute na lang natin guys, no? So, EI, then y is equals to 20 times 8.165 then cube divided by 3. Okay? Okay, so tingnan natin guys yung ating second term. Okay? Ano lang natin no? Yung ating second term guys, take note na yung x natin is 8.165. So kung pag sinubstitute natin guys yung x na equals to 8.165 dito, ang mangyayari is magiging negative yung ating pointed bracket, yung nasa loob ng pointed bracket. So therefore, hindi natin siya isasali. Again, no, take note, kailangan hindi nyo isali yung mga magni-negative, no? Kasi, syempre, no, di ba nga originally, dapat, meron tayong iba lang na moment equation na gagamitin para sa first segment. Ito kasi is para to sa lahat, sa last segment kasi to na equation, di ba? Sa last segment. So, hindi ito dapat kasali itong term na to kung sa first segment lang yung ginawa nating equation. Okay? So, minus, ayun, so minus 4,000 over 3 multiplied by x. Again, yung x natin is 8.165. Okay? So, ayun, so dito makukuha natin guys is EIY is equals to, kaya makukuha natin dito is negative, wait lang ha, negative 7257.75. Of course, this is in kilonewton cubic meter. Okay? Wait lang. Okay, so yun na guys, no? So, negative 7257.75. So, y dito sa kabila. So, ibig sabihin, no? Para sa y, that will be divided by, meron pa tayong EI guys dito sa may kabilang side. So, this is EI. Okay? So, kailangan lamang natin guys i-compute muna si EI, no? Okay? So, i-compute muna natin si EI para mas mabilis yung ating mamaya. Okay, so para sa EI, wait lang. So, EI. Okay. So, tingnan muna natin guys yung ating problem para sa value ng ating E at saka I. So, para sa E, sabi dito that is 200 gigapascal and para sa I, 700 times 10 to the 6 millimeters to the 4th. Okay. So, 200 gigapascal. So, this is 200. Gawin natin siyang megapascal guys. So, 200 times 10 to the 3 megapascal naman siya. So this is Newton per square millimeter times I. Ano nga yung I natin? 700 times 10 to the 6. This is in millimeters to the 4th. Okay, so mga cancel si millimeter square. So millimeter square na lang sa ibabaw yung matitira. Okay, so EI natin guys is equals to, okay, this is 1.4 times 10 to the 14 Newton millimeter square. Okay, so isa-substitute natin guys dito sa taas, kaya lang kailangan muna nating ma-convert nga itong kilonewton cubic meter na to Newton millimeter cube. Okay, so magiging negative 7257.75. Take note, sa kilonewton meron tayong 3 doon na times 10 to the 3. Ito is gagawin natin siyang millimeter, tapos naka-cube siya, so times 10 to the 9th na siya, plus times 10 to the 3, that is times 10 to the 12. So times 10 to the 12, ayun, divided by, so this is Newton cubic millimeter. Tapos yung EI natin guys ay ito, na ang unit is Newton square millimeter. So cancel si Newton, square millimeter cancel, ito matitira is isa na lang ng millimeter. Okay? So of course, no, ang lalabas dito na value guys ng y is equals to, ano natin? Okay? So y is equals to negative 51.84 millimeters. So ayun, so ito na nga yung ating sagot. Okay? So yun na nga yung ating guys, no, maximum deflection, no? This is the maximum, maximum deflection. Okay, so this is the maximum deflection na guys, no? So y max kasi nga yung ating hinahanap. So ayun, so this is the maximum, lagyan lang natin dito ng y sub max. Okay, that is the maximum deflection. Ayun, so last problem na tayo guys. So, tingnan natin yung ating last na tanong. Calculate the rotation of the beam at the right support in radians. Okay, so that means guys, ang kailangan natin ma-compute dito is yung dy over dx at x equals to 15. Di ba yung x natin is measured from the left support. So, right support man yung support C. So, at x equals to 15 yung ating x. Okay? So, ayun. So, isolve natin siya. Okay? So, dy over dx ang kailangan natin because rotation nga, no, at x equals to 15 ang kailangan. Okay? So, gagamitin natin dito guys yung slope equation. Okay? So, ito na nga guys yung ating slope equation. So, ayun. So, substitute lamang natin guys yung ating x na equals to 15 tapos dy over dx nga yung ating kailangan. Okay? So, bale, EI dy over dx is equals to 20 times 15, then square, then minus 60 times. Okay, so, okay. Kaya naman natin guys, no? Kung yung ating x dito is 15, then magiging positive nga yung ating nasa loob ng pointed bracket. So, okay lang. I-consider natin siya kasi positive. 15 minus 10, then square, then minus 4,000 over 3. Okay? So, this is the slope equation guys, no, na ginamit natin kasi nga, para lang klaro tayo. Ayun. Okay, so para naman sa ating, pag kinompute natin ito guys, no, ang lalabas is, wait lang, i-compute ko lang siya sa calculator. Okay, so ang lalabas guys is equal to 1, wait lang, this is 1666.67. So this is in kilonewton square meter. So ang kailangan natin guys is dy over dx, ayun. So bale divided by, meron man tayong EI dito sa kabila. So EI, okay? So of course yung EI natin nga guys is in Newton millimeter square. Tama ba? Ano nga yung ating value ng EI kanina? This is 1.4 times 10 to the 4th 14. Okay? This is in Newton square millimeter. Tama ba? Okay, so tama. Ayun. So, i-convert natin guys yung nasa taas to Newton square millimeter. So, magiging 1666.67 times 10 to the, yung kilonewton, convert natin to Newton, so times 10 to the 3 yun. Ito merong times 10 to the 6 kasi nakakonvert natin yung meter to millimeter. So, naka-square man siya, so times 10 to the 9 ito guys. No? Times 10 to the 9. Tapos, okay, so wait lang. Okay, this is a Newton square millimeter. And of course, divided by EI, na yung ating unit nga is Newton square millimeter. Okay, so cancel yung ating Newton tsaka square millimeter, kaya nga radians yung ating magiging unit dito. Okay? So ayun, so ating lalabas na sagot guys, dy over dx is equals to, this is 0.0, wait lang. Okay, so 0.01190 radian. So ito na nga guys yung ating lumabas na sagot. Positive yung lumabas na sagot. Okay? So tingnan nga natin guys yung kung tama yung ating mga naging ano kanina. Di ba? Siyempre, di ba? Positive yung ating inassume sa letter C. Tama ba? And then, negative yung ating letter B. Kung natatandaan nyo. No? Kasi nga downward yung ating deflection. Okay? So, ayun. So, positive yung C. Tapos, yung ating letter B is okay. So, this is negative. Okay? So, tingnan nga natin guys kung tama yung ating naging assumption kanina. Ayun. So, ito nga guys, no? So, ayun. So, yung sa letter B nga is negative yung ating naulahan natin na negative. Siyempre, kasi obvious man yun. Tapos yung letter C, of course, is positive, di ba? So, tama yung ating mga naging sagot. Okay? Yung mga signs. Okay? And tama din yung ating sagot. So, that's it, guys. So, i-review muna natin, guys, yung ating naging solution. So, ang una natin ginawa is, of course, kinuha natin yung ating mga reactions. Tapos, gumawa tayo ng moment equation by isolating the left side. So, ito na nga yung ating moment equation na gawa, guys. So, m equals to ito. Okay? Ayun, tapos, yun, so ito na nga yung ating moment equation, and then integrate natin siya para makuha si slope equation, wherein ito na nga si slope equation. Yun. And then integrate pa natin ulit siya para makuha natin si deflection equation, and ito na nga si deflection equation. Then, of course, meron tayong mga C1 tsaka C2, which are the constant of integration. So, para makuha si C1 tsaka si C2 ay kailangan natin ng boundary conditions. So, ginamit natin yung supports para sa boundary conditions. At ito na nga nakuha natin si C2. Okay? Tapos, nakuha din natin si C1. Okay? So, ayun. So, pagkakuha natin ng C2 at saka C1, of course, na kompleto na natin yung ating mga equations sa slope equations at saka deflection equations. So, pwede na natin ngayon nga masolve nga yung ating mga tinatanong sa problem. So, ayun. So, yung unang tinanong is yung location of maximum deflection from the left support. So, again no guys, no, para sa maximum deflection, yung ating slope doon is equals to 0. So, of course, ginamit natin yung ating slope equation na ito para makuha natin yung maximum deflection, yung location niya sa maximum deflection. And then, of course, tinanong din yung maximum deflection. So, para sa maximum deflection, ginamit natin yung na-solve natin na location, ayun. And then, gamit yung ating deflection equation, and then na-solve na natin yung maximum deflection na negative 51.84 millimeters. So, negative siya kasi downward yung ating deflection. Okay? And then, tinanong din yung ating rotation sa may right support. So, ayun. So, ang lumabas is, of course, positive. So, tama yung naging hula natin, guys. So, ayun. So, that's it, guys. So, madali lang naman yung double integration method. So, pwede nyo na lang i-supplement ito by self-study, no? So, kayang-kaya nyo na yan. Laban lang. Ayun. Okay? So, that's it. So, kung meron kayong tanong guys sa ating mga dinidiscuss, like for example, sa kakadiscuss pa lang na double integration method, no, pwede nyo i-comment dito sa baba sa comment section sa YouTube. Pwede kung nahihiya kayo guys, pwede kayong mag-email, no, para makashow kayo ng mga figures. For example, meron kayong problem na gustong ipa-solve, ayun. So, pwede nyo i-email sa akin. So, yung aking email ay eto. Wait lang, nasan na? Joker. Ayan. So, andyan guys yung aking email. That is marceljunior.abrera@gmail.com. So, ayun guys. So, don't forget to subscribe and pakisabihan na lang din yung inyong mga friends na nag-aaral ng structural theory na kung gusto nilang ng supplement na study, no, pwede kayong mag-subscribe sa aking YouTube account. That's it. That's it guys. So, ayun. So, bye-bye!